Alrighty, for number 13, C and D. For C, I have an isosceles triangle. I can tell because I've marked HI and IJ as congruent. If I follow those across, oh, I'm sorry, that was the wrong way to draw an arrow. This angle and across from this side is this angle. Those angles are congruent. This angle and this angle are congruent. That means they're the same. So this angle is also 3x plus 5. Now, I know that if I add all the angles of a triangle together, the angles, not the sides, the side lengths, your triangle could be teeny tiny, like 1 inch, 1 inch, 1 inch. Even though it's not inches, but it's just the angles that up to 180. So I can do 3x plus 5 plus 3x plus 5 plus 104 equals 180. Subtract 104, subtract 104, and I'll get 180 minus 104 gives me 76. And if I combine my like terms, I've got 3x plus 3x, which is 6x. This 104 was used, but I have plus 5 and plus 5, which is 10. If I subtract 10 from both sides, I'll get 6x equals 66. Divide by 6, divide by 6, and x is equal to 11. Then for D, I've got 106 here, 9x, and 12x plus 1. This 106 represents this angle right here. That is not part of the triangle. I need this angle for my triangle. Because 106 forms a linear pair with the angle I'm looking for, I know that when I add these two angles together, it needs to give me 180. I know one of them, so I can subtract that from 180 to find that this angle right here will be 74 degrees. So 180 minus 106 gives you 74 degrees. When I add those back together, I get 180. Now, I can add all my angles together and set it equal to 180 now. And I can do 74 plus 9x plus 12x plus 1 equals 180. Let me boop, 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 equals 180. 9x plus 12x is 21x. And 74 plus 1 is 75. If I subtract 75 from both sides, I get 21x equals 105. Now I need to do 105 divided by 21 to get 5. So 5 is what x is equal to. So again, we needed to solve for the supplemental angle to make sure we were using the actual angles inside the triangle. Add them all up, equal it to 180, combine our like terms, and solve.